So if we take a look at these, you might not know that this was the lemur, the first one, the second one was the pig, and the third one is the human. Their similarity, again, shows that they come from a closely related common ancestor. Now, let's take a look at a second piece of evidence of evolution. That's fossils and transition animals. So here's an example of a fossil. It's called Archaeopteryx. Archaeopteryx is a transition animal between birds and reptiles. What that means is that it's an animal that comes from a common ancestor and has both bird and reptile characteristics. A fossil is pieces of tissue that are left over, I shouldn't say tissue, I should say bone, that are left over from ancient organisms. They become part of the rock structure, and we can see bits and pieces of the structure of this animal. Now, based on scientists studying the fossils, they have come to the conclusion that if we put the tissue onto Archaeopteryx, it would look something like this. Now, what you can see with this, adding on all the tissue, it has teeth, that's like a reptile. It has a beak like a bird. It has scales. It has claws. And it also, you can see the feathers here. And feathers definitely not indicative of a reptile, but of a bird. So we have some similarities between the two species, showing that they are going into different directions in the evolutionary scale. Other things that we can tell from embryology, when you go to a museum, you might see a dinosaur with its tissue on top of its bone. The only way that we can create something like that is studying a bit of the fossils that we find near the bones of this organism. Now, we don't just find bones, but other things that we find is we might find egg, the shells of an egg. That'll give us an indication of how this organism reproduced. We might find feces, and within the feces we might find fossils of smaller organisms that this organism here has eaten. We'll see footprints. What did the foot structure look like? We also might see some of the skin texture within that footprint, and then we might get impressions of the skin. So using all of these pieces of evidence, that's why you see dinosaurs in their full form in a museum. But we never have seen one of those yet today. The other thing about fossils is that we can tell a little bit about the age of an organism based on the layer of depth in the earth that it lives. So if we find a fossil way down here, we can tell that it's really, really old. One that's in a middle layer is kind of medium old, and then we've got a younger organism up here. So the depth that we find a fossil will tell us a little bit about how old they are. We do have a pretty complete fossil record of horses. This is kind of interesting that if we go back about 40 million years, you can see that horses were the size of a small dog. So imagine that you have a big, large horse, and 40 million years ago, it shrinks down to the size of a small dog. Now, over time, we can see based on going into different environments and being adapted or being favored by the traits that it has, we can see that these horses have changed over time.